Hey everyone, we are going to be looking at distance, displacement, and acceleration. Along with that will be velocity, of course, because you can't have these two without velocity. And you're probably thinking, but wait, we've dealt with this already. And we did, but this is the order we did things. We had, we'd start with displacement and we would go to velocity, we would go to acceleration, and we would do that by deriving. So it makes sense that we can go the other direction with integration. And that's what we're going to be doing today. So if you have velocity, you can get to displacement. So displacement is going to be the integral from A to B of your velocity. Easy peasy, right? Hopefully. Okay. Now, distance is a little different because, if I start walking backwards, I would have a negative displacement, but I wouldn't have a negative distance. That doesn't make sense. Or if I walk, say, 1 step forward and 3 steps backwards, 1 forward, 3 back, I would be 2 backwards. So my displacement would be -2, but my distance would be 4. So the way we find our distance is by integrating from A to B the absolute value of your velocity. Be careful with where you place those absolute values. They need to be inside the integral, so between your integral sign and your dt. If you did it on the outside, you would just have the positive of your displacement. So you have to be really, really careful with where you locate this absolute value. In fact, I'm going to point it out so much by changing the color of it. So that's what our distance is. Okay, so before we go to our first example here, I actually want you to hit pause and read through example 1 on pages 502 and 503. I thought about making a video for it, but actually it's fairly straightforward and clear. So I'm like, you can take a look at that example rather than me leading you through it on a video. And then once you read through that, you can hit play again and continue. Okay, so here's our example that we're doing. So we're going to find an equation for velocity if acceleration being t to the -1. I forgot to put this in, and that's in centimeters per second per second. I know some of y'all like to write centimeters per second squared, and I hate that unit because what's a square second? So we're given an acceleration equation, and we want an equation for velocity. We've done it in reverse, right? We've gone from velocity to acceleration. We're going backwards. The only thing we need to know besides this is some point. So what if we're told, at time 1, we have a velocity of 0.1 centimeters per second. I know that could be a millimeter per second, but that would be switching units. I don't want to do that. So to do this then, our velocity is going to be the integral of t to the -1 dt. Which you might recall that is really, because if I add 1 to the exponent, divide by the new exponent, it's falling apart. That's just a dt over t, and by now we know this guy really well. So our velocity is the natural log absolute value t plus c. Now if we think about this logically, and also because we're not going to be dealing in negative times, I mean you can sort of have negative time because of going, if you say 5 seconds ago would be a -5, but we're going to just consider positive times. So we actually aren't even going to need the absolute value on that. To get our c, we simply plug in the 1 for x and the 0.1 for y. So I have 0.1 for my v, natural log of 1 plus c. Natural log of 1, of course, is 0, so c is 0.1. So we have v equals natural log t plus 0.1. And I'm dropping my absolute values just because we're only going to be in positive times. Okay, so if we want to know, so here's our velocity. And this is what this graph looks like. So at time 1, your velocity goes from negative to positive. So if we're looking at the time interval of 0.4 to 1.6, you have some negative velocity and some positive velocity, or in other words, this thing, you're going backwards and then you stop and then you go forwards. So it's essentially what's going on with that. So to find our displacement, remember we just integrate from point A to point B. So displacement is going to be from 0.4 to 1.6 of natural log t plus 0.1 dt. And remember, so right now I already have this equation in my y1. And remember, this is not something we can integrate because we don't yet know what has a derivative of natural log t. So we're going to do this here. So remember math 9, and our integral shows up. And I know if you have an 83, it looks a little different. Hopefully by now you're cool with that. So we have 1.4 to 1.6. And rather than, I could type in that natural log t plus 0.1, or I can do the alpha trace and 1. Remember, if you have an older calculator, vars, y-vars function y1 to get the y1. And so here is my displacement, 0.038. Now to do my distance, again, we're going to go 0.4 to 1.6. And this time, though, it's going to be the absolute value of this natural log t plus 0.1 dt. So to do this on our calculator, if I do my math 9 again, to me the easiest, and I'll put my 0.4 in and my 1.6, to me the easiest place to find absolute value is actually in the catalog. If you hit second and then 0, which is where the catalog is, the first thing listed there is absolute value. So I can hit enter, and then I can put my y1 in there. So I have absolute value of y1. And my x, and this will be a little bit slower to calculate. We have to wait a little while, and we get 0.395. So since we had a negative velocity and a positive velocity, it makes sense that our distance is greater than our displacement. So that's something that, remember that your distance is never going to be more than your displacement. It could be equal to it, but never more. Certainly not less. So we have 0.395. And remember that when we're doing these things, we always get 3 decimal places into our answers. It doesn't matter if we round or truncate, like I could have said 0.039 or 0.038. So I think it's safer just to go with the first 3 decimal places and chop it off. I know it's really terrible, like science and, reality, but this is what College Board allows. So that way you're never going to make a rounding mistake if you're just writing the first 3 decimals down and being like, ta-da! So you're going to be using your calculator a lot on the assignment. This is definitely something you need to know how to do on your calculator. It makes life easier, especially when it's something like this, when we can't actually integrate it by hand, at least not with our current knowledge. So make sure that you have read through that example 1 on page 502 and 503. And then you also have this guy, and you'll be good to go on this portion of our assignment.